Today we are going to finish the article, Chilling Out, Warming Up. We've read and watched the part 1 and part 2 videos already, as well as answered questions about them. Make sure you remember what it was and those are about. If you don't, you might want to go back and review the videos. That would be helpful since we will have a test over this information. Today we're going to start on the section that is entitled Hibernation. It is on page 8 of the article, so we will begin there. Hibernation. For warm-blooded animals that don't migrate, one way to survive the winter is to sleep through it. Hibernation is a great strategy that enables animals to conserve energy when food is scarce. During hibernation, body temperature drops, breathing and heart rate slow, and most of the body's metabolic functions are put on hold. It is almost as if the warm-blooded animal becomes cold-blooded as its body temperature drops considerably. But they're still alive, and they live off their fat reserves. Hibernation for extended periods of time is accomplished only by those animals that can store a great deal of body fat, such as bears, groundhogs, and chipmunks. A black bear loses 15 to 30% of its weight while hibernating. Cold-blooded animals hibernate too, but they need to store less fat than warm-blooded animals because they require less energy. Turtles and frogs bury themselves in mud under lakes and ponds for up to 6 months at a time, and for all practical purposes, they appear dead. There are no external signs of life. When many cold-blooded animals hibernate, something interesting happens at the cellular level. The fluid around the cells, but not in the cells, is frozen solid. As water freezes outside the cell, water from within the cell is drawn out through osmosis. Osmosis is a process in which water moves across a semi-permeable membrane, in this case the cell membrane, from an area of low solute concentration to an area of high solute concentration. As water freezes outside the cell, the solute concentration increases because the quantity of liquid water decreases, while the amount of solute stays the same. As a result, water flows out of the cell to equalize the concentrated solution inside of the cell, and that's shown in figure 2. At the same time water is leaving the cell, glucose migrates into the cells in copious amounts. As a result, the concentration of dissolved solutes within the cell increases a lot. The glucose acts as a natural antifreeze, as any solute will lower the freezing point of a given solvent, in this case water. The presence of high concentrations of solutes in the cells allow animals, such as frogs, to hibernate at temperatures below freezing and still survive. While the water around the cells is frozen, the water in the cells is not. If water within a cell were to freeze, the cell membrane would rupture, killing the cell. If we look on page 8, we're going to read the section with the hummingbird next to it called short-term hibernation. Some animals, such as hummingbirds, undergo a short-term hibernation known as torpor. Their nightly torpor is an energy-saving mechanism as their tiny bodies lose heat rapidly. They must feed constantly during the day to keep their body temperature up and maintain their incredibly fast metabolism. They eat 2 to 3 times their body weight every day. If they didn't enter torpor at night, they would die because their bodies would lose too much heat due to their large surface area to volume ratio. They also lack the insulating down feathers that many birds have, resulting in heat loss. We're going to go back down to page 9 and read the sections Keeping Warm and Keeping Cool. Keeping warm. When it gets cold outside, you put on more clothes. Your winter coat does not keep out the cold, but rather keeps in the heat. Cold itself doesn't exist. It is simply the absence of heat. If you want to read more about it, see the article titled Why Cold Doesn't Exist on page 10. Animals, or birds and mammals, also rely on insulation to prevent heat loss. The most effective insulation traps air, since air is one of the best insulators. Wool tends to be warm because its fibers are curled, effectively trapping air and keeping you and sheep warm. Birds fluff up their feathers when they want to stay warm, since fluffing introduces air. For mammals without hair, insulation is accomplished by blubber, a thick layer of fat tissue which helps it to insulate an animal's body because fat does not transfer heat as well as muscle and skin. This blubber may be 2 feet thick in some whales. Whales, tuna, dolphins, and other warm-blooded marine animals also rely on another ingenious method to conserve heat. To prevent excessive heat loss from extremities such as fins and flippers, which are not well insulated, aquatic animals rely on a counter-current heat exchange method, in which the arteries that carry warm blood away from the heart are positioned directly against the veins that carry cool blood to the heart. So the warmer blood leaving the heart through the arteries warms the cooler blood entering the heart through the veins. In contrast to birds and mammals, lizards, frogs, snakes, and other cold-blooded animals do not need Insulation. It would only slow down heat transfer into their bodies. Keeping cool. When you get hot, what's the first thing that happens? You start to sweat. The average adult has 3 million sweat glands. Evaporation is an endothermic phase change, meaning it must absorb energy to occur. This energy is drawn from your body, making you cooler. Anytime you lose energy, your body will feel cool. Evaporation requires energy because forces of attraction between water molecules, called intermolecular forces, need to be overcome when water goes from a liquid to a gas. The energy that goes into overcoming these attractive forces comes from your body. Do animals sweat? Most don't, but some do. Dogs sweat mainly between the pads on the bottom of their paws. One notable exception is the American Hairless Terrier, which is in that picture, which has sweat glands all over its body, illustrating the fact that fur tends to inhibit sweating because if the sweat can't evaporate, it doesn't help in the cooling process. Cats have sweat glands only on the pads of their feet, but also on their tongues. When a cat licks itself, it may not be only to keep clean, it could also be to cool itself because the saliva on their fur evaporates. Kangaroos will lick their forearms for the same reason. The key to surviving in hot climates is not only to keep your body from overheating, but also to prevent water loss. Animals that are adapted to desert life are not heavy sweaters because water is scarce. They cannot afford to lose water by sweating. Also, a great deal of water is lost through breathing out, so desert animals expel dry air, reabsorbing the water in their breath before it has a chance to be expelled. The ability of animals to survive in extreme environments is quite remarkable. Whether it is in the freezing corners of Siberia or the sizzling hot desert of the Sahara, animals have found ways to adapt and thrive, and how they do it will never cease to amaze us. That's the end of the article, Chilling Out, Warming Up. I hope that you've learned some ways that animals can adapt to their environment through different things with their bodies. I hope you have answered all the questions correctly because we're going to have an assignment and this will be on your test.